Well, howdy there, Internet students. This is Mr. Hermanson. We're going to start Chapter 2 today, Ratio and Proportions. Proportions are a really powerful way to solve problems, and you'll see that today. Okay. Basically, what we're doing is just changing fractions around. So if you remember doing that last year, you will have no problem with this. But you'll see that it's a very useful process. Okay. So just to give you a quick overview of what's going on here, let's say that in order to make the perfect strawberry milkshake, you need 2 parts of ice cream to 7 parts of milk. Now here's one way you can show that ratio using a colon in between. You could also do it this way. You always have to remember what means what. The 2 up top means strawberry ice cream, and the 7 means milk. Now, if you decided that you wanted to make one of these milkshakes for you and one for your friend, you would need 4 parts of ice cream, and now I'm sure you could tell that you would need 14 parts of milk. So basically, we're doubling the recipe, right? Well, there are a bunch of other options you can do. I mean, if you're feeding a crowd, maybe you want 10 parts of ice cream, which is 5 times bigger than that number. Then you would need 5 times as much milk. That's how that works. So you would need 35 parts of milk. Okay, so and when we have 2 ratios like this, where we have 2 sevenths is equal to 10/35, we say we have a proportion. Proportion means you have 2 equal ratios. All right, so we're going to work with that and solve some problems using that. Over the next couple pages here, there's a bunch of definitions. So if you ever hear a word that you're not exactly what it means, know that you can go there, and also some blank papers. Okay, now in order to give you an idea how this ratio stuff works, we're going to watch a quick little video about Nana's chocolate milk, and then we'll talk about that. Sorry guys, that was the wrong video. Let's try this one.
Oh no. He hasn't killed me.
Okay, so he mixed it a little bit wrong, but let's just talk about what's going on here. Maybe there's a way you can fix it. We're not really sure, but so if we put these on a number line like this, we can see that 1 cup of milk right here would be the same as 4 scoops of chocolate. So if I went to 2 cups of milk, which would be here on the number line then, right? Then that would be 8 scoops of chocolate. 3 cups of milk would be 12 scoops, and so on. So one thing he can maybe do is just keep scooping. So he had 5 scoops in, which is right there, until he gets enough for 2 cups. The problem is that he doesn't have a big enough glass there for 2 cups. So he needs to some other way fix it. Now, if a glass had nice lines on it, we would see that we need 1 1/4 cups milk for 5 scoops, which is kind of hard to estimate that quarter, but maybe we could estimate the half right here. 1 1/2, this is 1 1/2, right? Halfway between is exactly 6 scoops. So if he puts in 1 more scoop, then he can do 1 1/2 cups of milk. And I'm not sure if that's what he did, but we could find out. So check these ratios out. So 1 cup of milk, 4 scoops of chocolate, 2 cups of milk, 8 scoops of chocolate, 3 cups of milk, 12 scoops. Notice I could just do 1 times 3 to get this, and 4 times 3 to get this. Okay. Now, also, if you have 1 1/2 cups of milk, if you multiply that by 4, that equals 6. So that would work for 6 scoops of chocolate. All right, so let's check out and see what he did. All right, and then let's do another problem about Nana's eggs to help us understand how, if the numbers don't work out so right, we can still do ratios with them.
Oh no. Nana's gonna kill me.
All right, so let's see what we can do to help fix them up here. On this one, we're gonna we see that the recipe was supposed to be 2 eggs for every 3 tablespoons of flour. I think so that it kind of tells me that we have thirds here. So I think what I'm going to do is I'm going to put 1 egg right here and 2 eggs right here. Now that means that this here is 3 tablespoons of flour, right? Okay, so this is 1 tablespoon of flour and this is 2. Now we saw that he put in an extra tablespoon. He put in 4. So I'm going to pause right here and see if you could figure out a way we could fix this one. Now, you guys probably know that you can't have part of an egg, right? So, so we need to have one of these whole numbers of eggs. So there's a couple ways you could fix it. You could do, since he already has 4, you could do another 1/2 tablespoon. That's possible. So 3 eggs and 4 1/2 will give you the same ratio as 2 eggs and 3. 4, you could put in 4 eggs then and go with 6. That's a heck of a big breakfast, but those are some possibilities so that you get the same ratio. Okay, so we use ratios in a lot of things, like if we're making a replica model, we're going to use a ratio, okay? And the scale is the comparison of those measurements. So the Empire State Building is 1,250 feet tall. We're going to compare that to our scale model, which is 2 feet 1 inches, but that's not a really nice number to put in a ratio. we're going to just use the 25 inches there. Now, this ratio, you guys are probably thinking has a simpler ratio, and in fact it does. We could divide both these by 25. 25 is a common factor there. So if we divide them both by 25, I believe we get 50. So let's write that down so we kind of remember, divide them both by 25 over 1. So for every 1 inch will be 50 feet in real life is what that means. Okay, now we're going to use that idea to figure this out here. What if we wanted to make a scale model of the Willis Tower, which is 1,450 feet tall? So here's what our proportion would look like. You have to remember your which stands for which, but so we have 50 feet of the actual building, and then our scale model, we'll call that our model, is 1 inch. So for every feet we use 1 inch. Now we have 1,450, so we're going to put that up with the 50, and we want to know how many inches that would be. So I'm going to put a question mark there. Well, we got to figure out how many times bigger this is than 50. The way you figure out how many times bigger it is you divide them, right? Multiplication and division are inverse operations. So, so 50 goes into 1,450 29 times. Now that means our model has to be 29 times bigger than this 1 inch. So we're going to multiply that by 29, which is 29. And that's our answer, 29 inches tall. All right, let's try another problem. We're going to first write a ratio. In this case, we're going to do white tiles to black tiles. And we always like to write our ratios as simple as possible. But so we're going to count the white tiles, 1, 2, 3. And we're going to count the black tiles, 1, 2, 3, 4, 5, 6. Now you guys can probably tell that that's a nicer ratio would be 1 white tile to 2 black tiles. That ratio is a half. Okay, so the entire wall, remember this is only part of that wall, is 900. So I'm going to use my ratio of 1/2, which means 1 white tile for every 2 black tiles, to figure out how many white tiles I'll have in the entire wall if I know that there's 900 black tiles. Now notice I put the 900 on the bottom because this represents 2 black tiles. Okay, so I have to figure out what number times 2 is 900. So I'm going to do 900 divided by 2, which is 450. And then I need to scale this number up by that amount. So 1 times 450 is 450. And that makes sense because 450 is half of 900, right? Another way we can look at that ratio is the white tiles to all the tiles in the pattern. Okay, so and we can just count them if we want. There's 1, 2, 3 white tiles. And the total number of tiles includes the white and the black. If we add those together, we get 9 total. So that ratio is 3 to 9. Okay, now you guys know that that simplifies to 1/3, and we get that by dividing both by a common factor. Okay, so 1/3 is a nice little ratio. We want to know how many white tiles are in the whole thing. If there's 2,880 in all, and so the 2,880 goes on the bottom where the 3 is. And so I have to figure out what number times 3 is 2,280. So I'm going to divide that by 3. And that gives me 960. So the top number, multiply 960 times 1, that's 960. Basically, this ratio has to be 1/3. So 960 is 1/3 of 2,880. Another way you could get that answer is divide 2,880 divided by 3. Go ahead and be creative with your math as long as it makes sense. Okay, let's try another one. And you can go ahead and pause and try these on your own if you want. But we have a necklace here, and in order to make this pattern, we need some white flowers and some pink flowers. I noticed that it starts with pink, ends with pink, and then there's some pattern in between there. The ratio of white flowers to pink flowers, though, is it looks like there's 10, if I count them, there's 10 whites and 8 pinks. Now, since those are both even, I can divide them by 2 and simplify that. It's nice to have the simplest fraction possible. Okay. And so Tahani wants to make a longer necklace, and she's going to use 20 pink flowers. So you got to go back here and think which of these were the pink. Since it says white to pink, pink is the bottom number, 4. So I'm going to put 20 on the bottom. 5 over 4 equals some number over 20. Okay, now I know 20 is 4 times bigger, or is 5 times bigger than 4. So I'm just going to multiply this by 5, and that'll tell me how many white flowers I need. Okay, now the ratio of the total pink flowers to all the flowers, well, all the flowers in the necklace, it takes 18 flowers to make that necklace. And the pink flowers in there there's 8 of them. Now simplifying that, since those are both even, I'm going to divide both those by 2. That's 4/9. Remember that the bottom number is the total number of flowers. Okay. Now if Tahani wants to make a necklace using 27 flowers in all, that 27 goes down by the 9. All right. And so we know that 9 times 3 is 27. So scaling this number up, we would have 4 times 3, which is 12. So she needs 12 white flowers to make the necklace. All right. Ratios can also happen in problems where you're traveling. Okay. So this graph represents a canoe trip with the progress of the trip. And if you look closely, at the beginning they've gone 0 miles, right? So miles are over here. Time is over here. Let's go to the 1 hour mark and go over and look at the line, and you can tell that they've gone 4 miles in 1 hour. And at the 2 hour mark, they've gone 8 miles. So the rate is how many miles they've gone compared to how many hours. So we could do 8 divided by 2. And sometimes you'll hear somebody say miles per hour because it's 8 miles in 2 hours. Or we could do 4 over 1. Those are proportional. Either of those will work. So how many miles would you expect Carlita to canoe in 3.5 hours? Well, it looks like we're going 4 miles for every 1 hour, right? So 3.5 hours is 3.5 times that 1 hour. So we could just do 4 times 3.5 to get that answer, which is 14 miles. Okay. What is the ratio of distance traveled to time? It's 4 miles per 1 hour. Or here's the short way some people write it, 4 miles per hour. But that's what that miles per hour means. It's a ratio, actually. Okay, one way to tell if your ratios are equivalent is by dividing them out and see if you get the same decimal number. If you do, you have equivalent ratios. All right, that's it for today. Good luck with that lesson, and see if you can do those homework problems. Remember, if you get some wrong, it's not a big deal. I'm not grading you on your daily work. I'm only grading when I've expected that you should have learned it by now. Okay, and that's your test. So good luck with that, and we'll talk to you soon.